Today, I will talk about the automated design of patient-specific implants. Firstly, I would like to talk about the background of this project. Currently, there are two main limitations with conventional orthopedic implants. The first one is that implant design requires manual modeling by experts. And the second one is that the process is time-consuming, non-standardized, and prone to variability. So to deal with these issues, I suggest a solution, which is automation of the overall process. Next, I will talk about the significance of this study. As the population is aging, there is a greater demand for orthopedic patient implants. However, the inconsistent quality of the implant across institutions and hospitals may lead to poor implant. So, to deal with these, I suggest automation of the process, which will provide a novel alternative approach with fast, precise, and patient-specific solution. And this will draw out the prospects with improved surgery outcome, reduced healthcare burden, and expansion of the treatment access to underserved individuals. So for this study, I state the main goal, which is development of an AI algorithm for construction of patient-specific implant design. And this will encompass extraction of bone geometry from medical images, generation of customized 3D models based on the images, and exportation of the 3D models as CAD format for generation of the implant. Next, I would like to talk about the approach. In this study, there will be 4 key approaches involved. The first one will be segmentation of the patient's anatomy from CT or MRI scan via AI algorithm. The next step will be generation of the patient-specific 3D anatomical models using the segmented images. The next step will be computational modeling via AI algorithm of the patient model with biomechanical rules. And lastly, there will be validation of the automated design with clinical oversight. Next, I would like to talk about specific aims of the study. In this study, there will be 3 key objectives to be achieved. The first one will be designing AI-based image processing algorithm, which will involve development and validation of a robust AI module for medical image segmentation. The second objective will be automation of the model generation workflow. And it will involve creation of an automated pipeline for 3D anatomical model reconstruction and AI-driven parametric implant CAD generation. And lastly, there will be clinical and functional validation. via integration of the components into an end-to-end system to validate its performance via biomechanical simulations and to validate for its clinical safety and applicability. Next, I want to talk about pitfalls and alternative strategies. In this study, there will be three main potential challenges. The first challenge will be achievement of high AI accuracy across diverse anatomies from different patients. And second one will be managing the complexity of automated 3D design generation. And lastly, ensuring seamless system integration. So to handle these challenges, I suggest 5 mitigation approaches. The first approach will be iterative development with diverse datasets. The second approach is hybrid AI models integrating machine learning with explicit rules. The third one will be robust parametric frameworks. The fourth one will be modular software design. And the last one will be maintaining clinical oversight for complex cases. Next, I would like to talk about the impact from this study. There will be 2 possible impacts from this study, the 2 main impacts. The first one is improvement of clinical outcomes. So this study will improve the clinical outcomes and the clinical prognosis of patients via better fit and function of the artificial joints, fewer complications, and reduced revision surgeries. And the next key impact will be improvement in healthcare sectors and public health. And this will be achieved via lower healthcare cost, improved surgical efficiency, and finally, democratization of access to personalized orthopedic solutions. Thank you for listening.